So as I mentioned at the end of the previous video, we can also synchronize static methods and use static objects. Now when we do that, the lock that's used is owned by the class object associated with the object's class. Now synchronization is reentrant. What that means is that if a thread acquires an object's lock and within the synchronized code it calls a method that's using the same object to synchronize some code, the thread can keep executing because it already has the object's lock. In other words, a thread can acquire a lock it already owns. Now, if this wasn't the case, synchronization would be a lot trickier. Now, we'll sometimes see the term critical section used when discussing threads and synchronization. Critical section just refers to the code that's referencing a shared resource like a variable. Only one thread at a time should be able to execute a critical section. Now we'll also see the term thread safe used. When a class or a method is thread safe, what that means is that the developer has synchronized all the critical sections within the code so that we as a developer don't have to worry about the thread interference. So if we're using a method or class that isn't thread safe, then the developer hasn't added any synchronization. In that case, we'd be responsible for adding synchronization if we want multiple threads to be able to safely use the code. Now in the JavaFX section, if you've already done that, we learned that we would have to run all the code that modifies a UI component on the JavaFX runtime thread. So now I can explain why that is the case. None of the UI components are thread safe in JavaFX. So rather than forcing every developer to properly synchronize any code that modifies the UI, the JavaFX developers instead force all such code to run on the JavaFX runtime thread. Since only one thread, this is the JavaFX runtime thread, can modify UI components, there won't be any thread interference. So one last thing to note before we move on. When we're synchronizing code, we should synchronize only the code that must be synchronized. So in our example, only the for loop has to be synchronized, so that's why we put that inside the synchronized block. I demonstrated how to synchronize the doCountdown method, but doing it that way would be synchronizing too much code. We also don't want to synchronize the setting of the color variable because, frankly, there's no reason to do so. We don't want threads to be suspended or blocked unnecessarily because that can affect the performance of an application as well as the user experience. So, in other words, we really want to keep the code we synchronize to an absolute minimum. So at this point, we've now talked about and learned that we can prevent thread interference or a race condition by synchronizing critical sections of code. So let's go ahead now and look at methods that can only be called within synchronized code, namely the wait, notify, and notify all methods. So the classic example that demonstrates the use of these two methods is the producer-consumer example. So we're going to create a new console project and go ahead and create that now. So I'm going to close this project down. I'm going to create a new project and let's call it messages. Messages and finish to create the project. So what we're going to be doing here is pretending that we're dealing with reading and writing messages of some sort. And we're not going to use our thread color class for this example. So we're going to have two threads in our application. One that's going to produce messages and the other one that is going to consume messages. So first we'll add code for the message class to the main Java file. So let's add that class now. Class message. And we need a couple of fields. So private string message. And then private boolean empty. And we'll default that to true. We want to set up a synchronized read method. So it's going to be public synchronized string read. And for now, we're just going to put while empty and have an empty loop for now. And then we're going to set empty to be equal to true and return message. Then we also want to create a synchronized write method. So public synchronized void, because we're not returning anything, write. And the parameter that it needs, so the argument, is a message. And here we're going to put while not empty. Leave that empty for now. And set empty equal to false. Then this dot message is equal to the argument passed, which was message. So pretty straightforward. The read method will be used by the consumer to read the message, and the write method will be used by the producer to write a message. The empty variable will be true when there's no message to read, and we want the consumer to read each message before we write another one. So in the write method, we're checking to see if the message is empty. If it isn't, we're going to loop until the message is empty. When we exit the loop, we'll set empty to false, and at that point we then write the message. Now in the read method, we're going to loop until there is a message to read, and that's what the empty loop there is for. Then we'll set the flag to true to indicate that we've read the message, and then we return the message to the caller, in this case the consumer. Now I've synchronized the read and the write methods because when a thread is running one of these methods, we don't actually want another thread to be able to run either method. So we don't want the reader thread to run while the writer thread is writing a message, and vice versa. So now that we've done that, let's create our writer class, and that's the class that will actually write the messages. So we'll go ahead and do that. Class writer, and that's going to implement runnable. We need a private message, which is our message object. And then we need a constructor, which is going to store that message object. So public writer with message being passed as an argument to the constructor. And then we'll save it into our field. This dot message is equal to the parameter passed, the argument message. Make it a space here. Okay, so next we want to create our run method. So public void run. And we want to create a series of messages. So we're going to create a string array. So string messages is equal to, and let's just make it really simple. Humpty Dumpty sat on a wall. Humpty Dumpty, not really original, I know. Dumpty had a great fall. All the king's horses and all the king's men couldn't put Humpty together again. Okay, so there's 4 messages that ultimately we're going to write here. So then we want to create an instance of the random class so that we can have random delay. So create that instance. And we're going to loop through for all the messages. Even though we know there's 4, we'll actually loop through based on the length of the string array. I less than messages dot length I plus plus, which I'm sure you're very, very familiar with now. Then we'll do a message dot write, and it's going to be messages I. Go through and do one at a time. And then we need a try block here, so we'll try, and you'll see why. We're going to do a thread dot sleep. We're going to choose a random amount of time, so random dot next int 2000, so up to 2 seconds randomly. And we need to catch the interrupted exception, which we've talked about previously in this section. And we're not going to actually put any code in there for now. We'll do that if we find that there's some errors. Then after the for loop, we're going to put message dot write, finished. Okay, and clean up some of this space now. Okay, so that's our writer class. So the writer class, or in this case the producer class, writes 4 messages, and to give the reader, or in this case the consumer, a chance to run and to simulate what would happen in a real-world application, it's going to sleep for up to 2 seconds. You'll need to fix that bracket there, parentheses. So it's going to sleep for up to 2 seconds after writing a message, and I talked about using the random class to generate that random delay. So now that we've done that, the next thing we want to do is add our reader class, and we'll do that in the next video.